What is torque? I think that you should have some idea about this concept from your daily life. So take some time to make a note of what you think it means and what could be some examples of torque. At the end of the video, you can compare your background knowledge with the new concepts that you learn in this video. Torque is a concept that shows up in the context of rotational motion. We know that if we want to set an object in motion, we need force. We can ask a similar question. If we want to set an object in rotation, do we need force? Yes, we do, but it also matters how we apply that force. Let us understand this by looking at an example of opening a door, which is a rotational motion. Let's start with this example here. You want to open a door, but if you apply force at the hinges, you know that the door will not open. Actually, the hinges are the axis of rotation of the door. So if you apply force on the axis of rotation, there will be no rotation. Now, instead of at the hinges, you try to pull the door from the middle. Even if there is a door knob in the middle, it won't be that easy to open the door. Although there is some effect, the door will rotate, but it won't be that easy. Maximum effect would be produced if you have doorknob at the end, farthest away from the axis of rotation, farthest away from the hinges, and then maximum rotational effect will be produced. Let us look at this example. Here we are applying the force farthest away from the hinges, but we are pulling parallel to the door. The door will not rotate in this case either. Although the force appears to be farther away from the hinges, but if you imagine a line, and an imaginary line along which this force is acting, then this line of action of force actually cuts through the hinges. And again, no rotational effect would be produced. In this example, we again apply force, but not perpendicular to the door at an angle. Still, we would be able to produce some rotation in the door, but it won't be as great as when we apply force perpendicular to the door. Conclusion of this discussion is that it matters how the force is applied and there are different factors which are involved. Three factors that affect the rotation of the door are: how big is the magnitude of the force? Where are you applying the force? That is the distance from the axis of rotation, and how is the force oriented? So to make an object rotate, we have to apply force with leverage. We have to apply force at a certain distance and at a certain orientation. Based on this discussion, we can define that torque is turning effect of force. Let's now look at mathematical definition of torque. Because it involves force and the distance from the hinges, it leads us to define torque as force times lever arm. What is lever arm? It is the perpendicular distance between axis of rotation and line of action of force. Let's try to understand the meaning of this perpendicular distance by looking at the door example. Here is the top view of the example of rotating door. This is the point where force is being applied. So if you imagine a line, this is the line along which force acts. And here is the axis of rotation. So the perpendicular distance, which is from axis of rotation to the line where force is acting, is the lever arm. The important thing is that the force and the lever arm have to be perpendicular.